All right, folks, back with another video. Breadth First Traversal, Pseudocode to JavaScript. Simple and easy. Believe it or not, it actually is simple and easy. The way things become easy as a programmer, or really in any topic, is an understanding of the foundations of it. If you don't know the foundations of a binary search tree, or how to do the breadth first search, like the basics of it, I'm not talking about the code. The prior video, different video that I made, goes through definition, the why we use it, and the strategy of building the pseudocode and ultimately the JavaScript code, or any other code really. So I'm not going to go through all that again. What I will go over is that we discovered that we'll add the root and then add its children, or add the root, print it out, take it off, add its children, take off a child, print it out, add its children, right? That's the pattern. Pattern is take a node off from our list, add its children. Take a node off from the list, add its children. And as we're taking the node off the list, you could print that piece of data, or you could add that piece of data to your answer list. A simple array would do. And then the next question was, what kind of data structure does this need? Well, what's observed here with 9, 3, 18, and so forth down to 30 is that this is the first piece of data in. First, this is the last piece of data. If the first piece of data is the first one to come out, okay, then it's chopped off. This comes the first, that goes out. The last one to come out is 30. So first in, first out. First thing in, first thing out. First thing in, first thing out. So we know we need a queue. All right. Video's getting a little long. I probably lost some people. No big deal. Where's my eraser? Let's get an eraser. So I've set up the explanation. There's a more thorough explanation of how this is set up in the prior video. All right. Since this is a method on the object, I know that the root is available. I don't need to explicitly pass it in. And I need a list that I'm going to return instead of just instead of just printing to the console. So I'm going to pass in a list. I guess I should call it something, right? Answer list, something like that. And the way we would call that is we would make an object. Let's just call it, so my tree dot bft, and we send in an empty list. That's it. My tree dot function name, send an empty list. All right, now we know that. What if there's nothing here? What if I have no data? So the tree.root doesn't actually have any data in it. There's nothing, there's no value here. Something like that. You see no tree.root or no tree.root dot, like, for example, value. Like there's nothing there. We could just return false, or whatever you want to do. I'm just going to say return false. Okay, making it past that line of code, now we know we have something of value. We have a node with some value in it. And we discovered, to what I just did a minute ago, that if I have some data in my list, 9, 3, or 13, 8, 9, 3, 18, etc., as long as I have something in here, I can keep going, right? And I get them to when I add the 11 and the 30 as children, eventually they come off, and then I have nothing left. So I know that I could say, while, let's say, node queue, I'm going to say nq dot length. What does that mean? It means I also need to declare a node queue. All right, I have a node queue. Awesome. And actually, I don't even need to pass in an answer list, right? Because I can just declare the answer list here. So I don't even need to pass anything into this function. Let's do also ants list equals empty array. And I'm going to provide the code. I'm going to link the code to this video, so you could look at it as you're watching it. That's cool too, in case you just can't read this. But this is just me explaining how this code can be built up. All right. Now, something else we need to do here before we can even move on. This is good code, but we haven't put anything into that queue yet. So let's put something in that queue. This is good. This is good. We're getting somewhere. All right, so we want to put the 9 in the queue, and we know that, so let's leave some room here to actually get the 9 in there first. So I'm just going to move the line of code down. Node queue dot length. I'm going to fill this in a minute. Yeah, so what would we do if we have something in here? So we would probably say like current node, like cn is equal to node q. What's the method for taking a node off of or set a piece of data off of a queue? It's dq, assuming that you've got that method written. Otherwise, this is just a list that you can call it a queue. And if you're taking off from the first thing that was in, well, that would be a shift method. But we're going to say we have dq. So that's our current node. To get this current node, we need to declare it, right? So let's declare that. And to declare, we don't want to declare it just as nothing. Let's first declare it as the root node. That sounds like that'd be pretty smart. Current node equal tree dot root. Okay, we still need this length, and so you guess what's happening now. We're going to put the current node into the node queue. So node queue dot. Now this could if this was regular array, you push in your definitions of the object and the class. You probably have an nq method. And the nq method is just defined as an array push. That's all that is. Whoops. Yeah, node q.nq. We're going to pass in the current node. All right. Got a node. It's the 9. And right now we have, let's get rid of this. So we have the 9. Cool. Nice. So this is the node queue. And and then we'll have our answer list. I'm just going to look at as AL, answer list. So we've taken this off, take the 9 off. What do we do when we take it off? We can print it out, we can add to our answer list. Let's add to our answer list. So ants list dot push current node, right? Now it's here. And what did I say when we reach a node, we have to check its children. If it has children, put them in our node queue. Okay, so if we have current node dot left, and this would be with L, we would do nq dot that's funny, nq dot nq, node queue dot nq, the current node. Current node, we're looking for the left, so we'd nq current node dot left. Well, and same for the right, yeah? So if we have a current node dot right, we want to add that to the queue as well. So nq the current node dot left. Great. When I've taken off, 9 is here. We have a 3 and an 18. We have a left, we have a right. We're saying put those in the N queue. So 3 and 18 go in. Now what do? We come back to the top of our while loop. Does the queue have length? Does the N queue does a node queue have length? Yes, it does. So we dequeue it. There comes our current node 3. Answer list. Push on the 3. Does current node have a left? Does it have a right? And if so, put each one onto our node queue. Does 3 have a left and a right? Yes, it does. 1, 4. Great. Come back to the top. Do we have a length? Yes, we do. Current node dequeue 18. Push on 18 to our answer list. If there's a left, if there's a right, or this should have been right. If these things are true, put those nodes. If there's a left, put the left in of 18. If there's a right, put the right in. Great. Current node, DQ, 1. 1 comes off. There's no left, no right. 4 comes off. No left, no right. 11 comes off. No left, no right. 30 comes off. No left, no right. And then last but not least, jump out of our while loop. And we say return ants list. And you're done. I will link to the code in the description. Thank you guys for watching. Have a great day.